Hello! We started our discussion on voting mechanisms last time. We talked about the social welfare function, which takes the preferences of all voters and combines them into one preference for the society. The trouble with this is that any such functions with good properties also have the bad property. And that was the Arrow's impossibility theorem. Recall that unanimity means that if all voters agree on the relative ranking of two candidates, then the same ranking will happen for the society. IIA means that the relative ranking of two candidates for the society should only depend on the voters' rankings of these two candidates and not on the other candidates. And dictatorship means that there is one voter that the society always agrees with. We now give a sketch proof of this theorem. It is a nice proof, but also a little bit complicated. We will try to avoid the heavy notation that is necessary in the formal proof. And the proof will come in 4 stages. We first suppose that f is a social choice function that satisfies unanimity and IIA. In the first part, we prove that given a candidate B, if every voter ranks B at the top or bottom of their list, then F also ranks B at the top or the bottom. Suppose otherwise, and there exist candidates A and C such that F ranks C below B below A. We now take each voter's list and move C to just above A. Notice that the relative rankings of A and B do not change from one to the other. So, by IIA, the relative rankings of A and B do not change in F either. So, for the new voter preferences, F will rank A over B. We can make a similar argument for the relative rankings of B and C. They are still the same between the two lists. So F will also rank B and C the same, and it will rank B over C in the new preferences. Now there is a contradiction in here. What is the contradiction? Well, we see that C is higher than A in all the voters' lists. So by unanimity, C should be higher than A in F. And that contradicts the transitivity of F. So this shows that F must rank B at the very top or at the very bottom. And that completes the first part. In the second part, we want to find a potential voter that can be a dictator. We start by taking an arbitrary voter preference P. We then create a sequence of preferences P0 to Pn by first moving B to the bottom of everybody's list, and then move B to the top one voter at a time. We now look at how F ranks B in these preferences. We see that for P0, F must rank B at the very bottom. Since every voter ranks other candidates higher than B, F will also do so. That is by unanimity. Similarly, for Pn, F must rank B at the very top of the list by unanimity. For all the voter preferences from P1 to Pn-1, we know from part 1 that F also ranks B at the top or the bottom of the list. So going from left to right, F must switch from bottom to top at some point. Say the first time this happens is when we go from Pi-1 to Pi. This voter I will be a possible dictator for our function F. And the situation for Pi-1 and Pi looks like this. In Pi-1, voters 1 to I-1 rank B at the top, the rest rank B at the bottom, and so did F. In Pi, voter I switches B from the bottom to the top. and this causes F to also switch from bottom to top. So voter I is pivotal in changing the social preference for candidate B. We will now prove that voter I is a dictator. For part 3, we let A and C be two candidates other than B. They do exist since there are at least 3 candidates. We will show that F agrees with voter I on the relative ranking of A and C. Without loss of generality, assume that voter I ranks A above C in the original P. We now look at P, Pi-1, and Pi. And we will create a new voter reference P star from Pi by moving A to the top of the list for voter I. We first note that between P and P star, the relative rankings of A and C do not change. So, by IIA, F ranks A and C the same in P and P star. So the goal now is to prove that F ranks A above C in P star, hence agreeing with voter I in P. We now compare Pi-1 and P star. Notice that the relative rankings of A and B do not change between the two voter preferences. So by IIA, F ranks A and B the same in Pi-1 and P star. But F ranks B at the bottom in Pi-1, so it ranks A higher than B for both Pi-1 and P star. Similarly, we will compare Pi with P star. The relative rankings of B and C do not change between the two. So by IIA, F ranks B and C the same in Pi and P star. But F ranks B at the top in Pi, so B is higher than C for both Pi and P star. So we have that F ranks A higher than B and B higher than C. So, by transitivity, F ranks A higher than C, which matches the ranking for voter I on A and C. But A and B are arbitrary, so F agrees with voter I on the relative rankings of any two candidates other than B. This is not enough to show that voter I is a dictator. We still need to show that F agrees with voter I on any pair that involves B. And this is what we will prove in part 4. We let D be any candidate other than B. We will show that F agrees with voter I on the rankings of B and D. So there exists a candidate E that is not B or D, as there are at least 3 candidates. We will now run the arguments from parts 2 and 3 with E instead of B. This will give us a voter J such that F agrees with voter J for any 2 candidates that are not E. We will now show that these two are actually the same. Voter I is the same as voter J. Suppose otherwise. We have 2 cases. Let's say J is less than I. Consider the voter preference Pi-1. We see that F ranks B at the bottom, so F ranks D above B. For voter J, D is lower than B. Can you see a contradiction here? We know that F must agree with voter J in all cases not involving E. Since voter J ranks B above D, F also ranks B above D. And this contradicts anti-symmetric property of F. It ranks B over D and D over B. So this case is not possible. We now suppose that J is greater than I. We will consider the voter preference Pi. We see that F ranks B over D. but voter J ranks D over B, and F has to agree with voter J on B and D. So F must rank D over B, and that is a contradiction. So I is equal to J. Now parts 3 and 4 tell us that F agrees with voter I on the relative rankings of any two candidates. Hence, voter I is a dictator. And that completes our proof of Arrow's impossibility theorem. Now this theorem tells us that if we want to combine every voter's rankings into one ranking, then it is impossible to have all the good properties without being a dictatorship. In the next lecture, we will connect this to the social choice function, where we combine every voter's rankings and select one winning candidate.